So with the open authentication here, this gives us a way that allows us to transfer risk. What do I mean by that? Transfer risk. Why would OAuth transfer risk? Well, if you create a web app, let's say, or some sort of application, and you're managing the user IDs and passwords, there's a good chance that you're going to get overwhelmed because people are going to do what? Forget their user IDs, forget their password. So then we might code in some stuff to say, click here if you forgot your user ID, and then we ask some other cognitive questions. Or we say, hey, if you forgot your password, click here. And we'll reset your password and send you a new one. And because of that, user ID management is quite a big overhead for a lot of web apps that are out there. It's a big overhead. So you transfer the risk of that because usually the user ID and passwords will combine together, may contain PII, right? So what we can do is we can say, you know what, web app, I'll tell you what we're going to do. We're going to go out to Google and we're going to go to Google Developer. So in Google, you can set up a developer account, and inside of the developer account, you can set up your own key. So the developer, let's say the developer works for CyberProtects. You can do this with Facebook. You can do this with Apple. You can do this with, they got GitHub as an example here, Instagram, Snapchat, whatever you're using. If you are a developer for whatever platform, and we're going to use Google as one example here, you register as a developer for whatever organization you are, Google will issue you a key. That key belongs to that organization. Okay? What you can do with that key is now you take that key and you put that key into your web app right here. And what that does is that immediately allows the trust between Google and your web app to exist. So these two now have what we called earlier the realm of trust between the two. Right? So we create that realm of trust because Google now issued a key. This key is on this. They'll make you tell them your IP address, the web server. They'll make you tell them the URL and DNS information of that web app, so they know where it's coming from. So they can say, this is coming from this source. Yeah, I know that it's coming from this source. So why is that important? Well, instead of you taking care of all the PII, now when all these users want to come in and utilize, it's essentially a proxy. They hit up your web app. They want to authenticate with Google. They click that authenticate with Google. What your web app will do is it will pass that person right over to Google. Then you authenticate with Google. And then if you provided the right stuff for Google, then Google will pass back and say, yes, authenticate them. They've been authenticated, let them in. And Google provides you with less than 50 lines of code. All of them do this. Facebook, Instagram, Apple, all the big dogs out there that allow this open authentication. They provide you the source code, and what you do is you take that source code and you put it into your web app, and it automatically will work behind the scenes. It's just beautiful. It looks at the key. You got to put the key in their source code, and then you copy and paste their source code literally into your web app, and then now authentication magically works. It's beautiful how that works. And what they do is when they send this back saying, hey, this person has authenticated to Google, you can trust it because you trust Google, you can trust this person because they've authenticated. What Google will do is they'll provide you basic information like first name, last name, and probably their Gmail account. So ben.c.mcgee@gmail.com. And what Google has over here, though, is something like a directory server, like we'll say Active Directory, for lack of a better example. And underneath it here, they have your object deep in the bowels of their directory server. And so when you go and register or try to log in with an app over here using Open Authentication, it hits the Google provisioning service. That Google provisioning service will come down, check your user object, and then provision you coming back. And really, for anybody who is interested in doing any type of development, being able to transfer the risk to one of these 800-pound gorillas like Microsoft or Google or any of the other big guys that are out there, they've spent tons and tons of money making sure their stuff works. So there's no reason for us to develop a user ID and password if people want to use that single sign-on. If people still want to log in, they're going to forget it. They're going to forget it, right? Or they're going to write it down underneath their mouse pad or the keyboard, and we might be able to find it. So I say that because you'll probably see some of the trickier questions on your exam. You'll probably see the word federated identity. You'll probably see SAML. Know that SAML and SPIML are both XML based. And I showed you that format where they have those little caret tags in it. We'll call them alligator tags since we like gators around here. Greater than and less than sign. But that XML is how that SAML and SPIML is sent back and forth. And same thing with the Open Authentication. It's going to give you just an object that you can send back and forth. And so OpenAuth, single sign-on, SAML, SPIML, federation, these are all things that I would expect, if I was you, to see on